Hi, I am Dr. Lakshmi Sobi Beetle and I'm a lecturer in the Department of Civil Engineering at the University of Cape Town. I will share with you today one of my most recently completed research. Have you ever thought that just like humans have a certain physical strength, so do soils? In this research, we studied the strength of a soil and explored more sustainable alternatives to strengthening soil for construction. Now, you may be wondering why it is necessary to understand the strength of soils. Imagine yourself visiting a city where the infrastructure is impressive. That is, there are well-operated road networks, water and sanitation services, appropriate buildings of different sizes and shapes to suit different purposes, parks, and so on. Let me tell you, although there are specialist engineers for designing each of these, it requires an engineer to look at the strength of the ground and ensure that these can all stand in their respective places. If a ground is not strong enough to support a building, the building may start experiencing unpleasant cracks or may even collapse if the ground is extremely weak. Therefore, it is very important to have a geotechnical engineer as part of the engineering team at the onset of the project. In general, the geotechnical engineer investigates the impacts which earth materials like soils and rocks may have during a construction project. In the geotechnical engineering group at the University of Cape Town, we undertake intensive research works related to the improvement of ground properties. In this research, I particularly looked at one of the many methods which may be used to improve the strength of weaker grounds. Known as the granular column technology, this technique involves the installation of columns made out of sand in the ground, such that the ground becomes stronger and more stable for construction to take place. For the past few decades, this method of improving the ground has been used in many countries successfully. In fact, it is rather popular for its cost effectiveness and environmental friendliness. Talking about the environment, the construction industry is unfortunately one of the major contributors to environmental degradation. Some of the major environmental impacts of this industry include environmental pollution, resource depletion, ecological destruction, soil erosion, waste generation, and material wastage. Therefore, it is the responsibility of every stakeholder involved in the construction industry to ensure that more innovative ways are used during construction, which meets the demands of the client while aiming at the lowest possible damage to the environment. In this research, I proposed that the sand being used to make the columns for improving the ground should be partially replaced by a waste material. The big question here is, why use waste? At present in South Africa, we are facing a landfill crisis where we are soon going to be out of space to store our waste. Logically speaking, landfilling is no more an option, although we continue to do so. Therefore, I urge each one of you to take responsibility for the waste that you generate and to think about the destiny of the waste which our community is creating. I have attempted to do this in my research by replacing some of the sand with waste. This replacement not only aims at reducing the amount of waste being sent to landfills, but it will also potentially save on the use of sand, which is an important natural resource which should not be wasted. After all, resource recovery is absolutely necessary in present times. So, in my research, I have used plastic flakes which I obtained as a byproduct during the recycling process of polyethylene terephthalate plastic bottles. These are really big words, but in a sense, I'm referring to the PET1 bottles, which are generally used for packaging soft drinks, water, and juices. In the laboratory, I created a ground scenario within a metal tank and installed individual sand columns. I then applied a heavy load on top of the column to check how much weight it can actually support. To understand how the inclusion of the plastic bottle flakes in the columns affected the strength of the ground with the column, several laboratory experiments were carried out where different amounts of the plastics were used. It was interesting to observe that a normal sand column was able to improve the strength of the ground by about 70%, while a sand column containing plastic resulted in a ground strength improvement of approximately 140%. This latter improvement is twice that obtained in a conventional sand column. Now, this is very important information since the research has demonstrated that plastic bottle waste is a good material for this application and may therefore be recovered and utilized in certain construction projects. This observation has encouraged further research in this area to investigate other important factors related to the application of the technology before it can be adopted in the field. I end this video here in the hope that I have managed to inspire you to look at managing the waste which you generate in a different way. Also remember that as much as we need construction projects to meet our needs, we should aim to build responsibly and sustainably. Thank you.